RA then. Oh, pen went a bit not very well there. So R is always easy, isn't it? This guy squared plus this guy squared square rooted. Done, 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 done. 1 mark in the bank. That is my exact value of R. Okay, now the other thing, we need to expand out Rcos theta plus alpha. And match that up, match that up with what we've got here. So cos theta is here, allowing us to match r cos alpha with 5. Sin theta is here, allowing us to match r sin alpha with 2. And then this gives us the correct way up. Tan alpha is 2/5. Make sure this is the right way up. It's often the wrong way up in exams. I mean, like, students often have this the wrong way up. Okay, I've given my value of alpha in radians. I've given it to 3 decimal places. Well done me. I've also drawn all over my hand. Right, let's do the check, okay? You won't want to do the check because you'll think you're right, but it's just so good to get into the habit of checking your answers, especially when you're then going to use them to do something else. So you get your calculator, you type this in with theta as some number. I'm going to use 2.5. And that comes out to be minus 5.202662366. Now I'm going to put the same thing in here. Root 29 cos 2.5 plus 0.381. Fingers crossed we're going to get this, or at least like that. Yay! I've got minus 5.2033. Well, okay, look, it matches up to 3 decimal places, which is what I'd expect because I've only got alpha to 3 decimal places. So that's my check done. I know that I'm right, which means I can carry on with confidence. If you forget which is which with these reciprocals, look at the third letter. Third letter is T, third letter is S. That means that cosec is the reciprocal of sine, cot is the reciprocal of tan. And in this question, we need to somehow maneuver ourselves from a situation in which we've got cot 2x, cosec 2x, into cos 2x and sine 2x. So the angle's still 2x, that's not a problem. But the functions have changed from being reciprocal trig to trig. So I'm going to go straight in and write these in terms of sines and cosines. And then, as I always do in these types of situations, I'm going to sweep through with the denominator. I'm going to multiply by sine 2x, multiply by sine 2x, and multiply by sine 2x. And then, look, I'm done. 5 cos 2x, just put him on the other side, you go there, and we are done. And C is a positive constant, good, that's what I wanted. Let's move on to the equation. Now our manipulation here shows that this can be written like this, so I can take that one big enormous leap there and just jump straight to that. And then using my part A, I know that 5 cos of something minus 2 sine of something can be written like this. Now, this is where it often goes wrong for students, sadly, because this is essentially the easy bit. So let's take this nice and gently. I'm going to use a substitution. 2x plus 0.381 is going to become y, meaning that I can just solve the equation cos y is 3 over root 29. Much easier. The first solution comes from the inverse cosine, and that comes out to be 0.9799 blah blah blah. And I'm not going to round that because it's not the end. The second solution for cosine is just negative of the first solution. And again, I am not going to round that because I want to avoid premature rounding. That is a danger. If we chop this down and make it like 0.98, then use it and then use it a bit later, then our final answers down here are going to come out slightly wrong, and that will be truly sad. So let's get these two, let's get some more as well just in case. So the first one I've got here is minus 0.9799. I've also, I'm going to underline that's my first one. I've also got 0.9799, etc. It's etc. I'm not chopping it off at all. I'm going to use the full calculator display. Now if I want more, then I can get more just by adding and subtracting 2 pi. So to go from here to here, I just add 2 pi. To go from here to here, I just add 2 pi. If I wanted some more negative ones, which I don't, because I just want to go from 0 to pi, but if I did want more negative ones, I would subtract 2 pi, subtract 2 pi. And I can do that as long as I like, and I get loads and loads and loads of solutions. So in this case, we end up with 5.3 something or other here, and 7.26 something or other here, just by adding 2 pi. Now that little procedure, making that substitution, has made my life much easier because this was a simple problem to solve. Just shift cos, make it negative, add 2 pi. And now all I need to do is undo the substitution. So x will be y minus 0.381, all divided by 2. If I do that in the wrong order, I'm going to throw these marks in the bin. So be very careful with your rearranging. First of all, take off the 0.381 to give you 2x, and then divide by 2 to give you x. So let us do it. We've got this one, this one, this one, and this one, and we're going to subtract 0.381, then divide by 2, and we want things between 0 and pi to pop out. So actually I'm not going to bother with that one because it's already negative. If I take something off and then divide by 2, it's going to be more negative, so I definitely don't want it. So let's start with that one. This comes out to be 0.2994 when you apply this to it, and then this one, I'm just underlining so that I can track what's come from where. This comes out to be 2.4611, and then this one comes out to be 3.44 something something. Now, we only want to go between 0 and pi. Pi is 3.14, and therefore this is too big. So these are our answers. But we want 2 decimal places. So this is 0.30 and 2.46, not 0.3. Okay, 2 decimal places, and we've done what we were asked to do, and we've finished the question.